Hello, I am Meher Chand, and in the present lecture we will discuss about SymPy, which is most important library in Python. And using the SymPy library, we can do all type of scientific calculations and scientific computing. But here we are using the online version. You can open a SymPy library on any device, on your mobile, on your laptop, on your PC. Okay, I will provide you the live SymPy URL and you can easily open it. Just click on it. The most important thing is once you are able to use and understand the syntax of SymPy library, then you will be able to import this library in Python, and you can do numerous type of scientific computing and easy to control once you are able to understand the syntax which are we are using in the SymPy. The syntax which we will use in the SymPy will be same as we are using in Python. So the most important thing is anyone without any programming who never use any scientific computer or any device for the computing can do all these things by opening this SymPy library in any device. So let's start all these things. Just to follow my instructions and note all the points which I will present in this lecture. Okay. So first you need to open SymPy in your URL. Just search in Google. What you need to enter, just live.sympy.org. Okay. So when you will click in the Google, or you can directly use this URL at the URL place on your web, Google Chrome. Okay, so I am entering, and as soon as I will enter, you can see that this is a live SymPy library. Okay, and you can see there are several statements at this place when you will open this SymPy. The very first statement is Python console for SymPy for Python 2.7.18. Okay, and SymPy version is 1.5.1. You can easily import SymPy in your Python, but if you are a beginner, then we are using this SymPy library online mode. Second, we have, this is the very first statement, from underscore future underscore import division. So whenever you will enter any statement, and if there is any kind of error, it will declare the message, error message in runtime. See here, this is the prompt sign, and all the statements we can easily enter at this place. I am entering here pi. Okay, pi is one mathematical symbol, and as soon as you will click, you can see at this place, this is the pi. So pi is the syntax. When you will enter in the prompt sign, it will return the value of pi, and but here it will return the symbol of pi. Okay, if I enter here this statement pi, and when I will enter, you can see that there will be error message. Okay, it will return error message because this is no input in the, yes, you can see here is name error, which is pi is not defined in SymPy. So this is the importance of this statement. Now you can see the second statement. From SymPy import product sign. So when you will use this statement in Python, this will import all the functions, symbols of symbolic mathematics in Python. So this statement is used to import all symbols, functions to import from SymPy in Python. The third statement is XYZ is equal to symbols. Now when we are doing some symbolic simplifications, calculations, or we want to operate some operators on symbolic functions, in that case we have to define symbolic variables, integers and functions. So in this very first statement, we are defining here x, y, z, t. These are the variables which we will use for symbolic functions, for symbolic calculations, symbolic mathematics. And all these are easily defined by using the symbols function, and we can give the inputs at its place in quote symbol, and all the variables, as you can see on the left hand side, x, comma, y, comma, z, comma, t. You can also use comma in the place of space. So either you can use a space or you can use comma at this place, no difference. Okay. Similarly, we can declare the integers if these are useful in your programming by defining the statement. This is the statement to declare the integers. So k, m, n are the integers, and we are using the same function as we are using at this place symbols, but symbols are at this place integer. Okay, and the next statement, but last, is to declare the functions which work as a symbolic function. So f, g, h are the functions which will be used in calculus. Okay, so these are can be easily defined as f, g, h, and where cls means calculus is equal to functions. So in this lecture we are covering three topics which are related to calculus. First we will do differentiation, then we will do integration, and at the last we will cover limits. And I hope these three topics will be very useful, very informative, and create interest to learn the computing in mathematics. But these days computing in mathematics play a very important role for the scientific study. See, first I am using here some syntax. I am using here double product, x double product 2. This will double product is used for exponent. So when I will enter this statement, just you need to enter and you will see that this is x square. Okay, so x double product is used for exponent. Similarly, you can see x and y. So this will return the value is x raised to power y. So double product means exponent. Similarly, square root. For square root, we are using sqrt. This is the function, and suppose it is 5. When I will enter, you can see that this is square root of 5. So these syntax are very important in the beginning. And Python also work like a calculator. You can do, if you want to divide any number with another, 8 is divided by 2, and when you will enter, it is 4. So backslash is used for division, and for the subtraction, 8 minus 5, the symbol is used for subtraction. Okay. And for the product, we are using single product sign. This will be return the value 16. So these are the basic notations which are highly useful, and one need to understand so that these can be easily used for different type of computing operators. Now we are choosing a very simple function. F is equal to, I have suppose that this is a sine function. Okay, the beauty of this SymPy and the Python is that as we speak, we need to write in Python. So anyone who never use any programming or learn any programming can use Python for scientific computing. So this is the very interesting and beauty of this Python. And the syntax which we are using in SymPy in live mode, you can use all these offline mode also. And whenever we will start to use Python, and we will import this SymPy library in the Python, and we will do all these things, and we will implement a different type of operations, mathematical modeling, many things we can do. And we are starting from the very basic so that you can understand all these notations, and then you can use all for the scientific computing. So in the very first, we are discussing about differentiation. We are choosing here very simple function, f is equal to sin x, and if you will want to print this value, so this is sin x. Okay, so this is the printing value. Now if you want to differentiate, then we need to this function, and we want to differentiate f with respect to x. This is ordinary differentiation. Okay, so when you will enter this statement, you can see that the derivative of the above function is cosine x. If you want to take second order derivative, this is also very simple. Just use the function diff f comma x comma x. So x is 2 times means it is the second order derivative of f with respect to x. See, so the derivative of f is sin x, and again we will differentiate, then it will be derivative of sin x is cosine x, and again when you will differentiate the same function 2 times, it will be minus sin x. And similarly, if you want to differentiate 3 or 4 times, it is very simple, x comma x comma x comma x. So this will be fourth order differentiation, and you will see the corresponding value. The another way, which is very simple to find out derivative of any order, we are using here f comma x. Okay, and comma, I am entering here 4. So this will return us the derivative of f with respect to x, fourth order derivative. And when you will enter, see, this is also sin x. So either you can use this statement or you can use this statement. These are the different two expressions, but the operation will be same. Either you can use the previous one or you can use second one, and you can see that the corresponding result we have same. If you are using a function like in this way, fun is equal to I have sine x square, and then enter it, and fun is equal to function like sine x square. Okay, now if I am writing here derivative, this is the just a symbol or notation, derivative of derivative, then fun comma and x. See what happened and enter derivative is equal to yes. So when you will use this derivative function in this form, d is uppercase, and then you are using at its place function and comma x. So this will return the value without evaluating the function or without operating the operator. And you can see the syntax at its place. This operator, meaning the meaning of this operator is ddx of sine x square. And when you will use this left hand side assignment, this will return the corresponding input. So if you want to operate ddx on sine x square, what you will do or what is required? We use here do it function. So by using do it function, the operator which we are assigned here will return the corresponding result. How we can use? See here, the assignment is deri, deriv, then dot, then do it function. Then we are using do it and enter. So you can see in the very first statement we have the assignment only, and in the second statement it is returning the value without evaluating it. Okay, but we need the derivative, or we want to use this operator on the assignment. Then for that case we have to use this function do it. So do it will apply the operator which we have defined in the previous statement. Also, if you are using the same, like see here, I am using diff function, and this is a sine x square. Okay, and with respect to x, and then enter. So you can see here, either you can use in this way or you can use in this way. We have the same function and the derivative of the both we have returning the same value. So it depends upon you or your convenience how you want to use these operators for differentiating. Now if we have the function of multivariables, or we want to take a partial derivative, then that is also very simple to operate. See, Suppose that I have a function f is equal to, I am using here sine x square plus y square and again plus z square. I have x, y, z, three variables are already defined, so I can use them directly. So this is we have f function. F is the assignment, and we have sine x square plus y square plus z square. And if you want to print, then you can use in this way, and you can see this is a sine x square plus y square plus z square. So we want to use some operators for differentiation, and this will be partial derivative. It is very quite simple to use and to apply. See, I'm using here again diff whether you are differentiating ODE or you need partial derivative, both have same function. So derivative of f function with respect to x, and when you will enter, we have this is the derivative of the above function. Again, diff f comma y and enter. This is the partial derivative of f with respect to y. Similarly, you can use for f with respect to z. Okay. Now, if you need second order derivative, the process will remain same as we do for the previous single variable function. See again, diff f comma x comma x. Okay, and if sometimes we need mixed order derivative, say diff f comma x comma y comma z. I am using in this way. Suppose it is fun is equal to derivative. See what it will return. Fun and C. So this is the third order partial derivative of the function with respect to x, with respect to y, with respect to z. And if you want to evaluate the same, then we are using here do it function, do it. Okay, and when you will use do it function, it will return the its value, and see this is the corresponding value of the above operator. After simplification, we get this value, and it is very quite simple to implement. Sometime we need the derivative like in this way, fun, and say I want to differentiate f with respect to x 2 times, x second order derivative, y one order derivative, z again I have a second order derivative. Okay, and then enter. Okay, it is asking sign object is not callable. Okay, function. Okay, so I entered here the statement is incorrect. We need to make it correct. This is the beauty of the very first statement which I explained in the very beginning. We have to use here diff function. Okay, now it will return the correct answer. So after simplification, you can see this value. This is the derivative of the above function, and you can check the corresponding value at this place. Also, you can make its full size. If you want to make full size, just press at this place. Yeah, it's look very awesome. So you can see now the full value at this place. So these are the basic operations for derivative. For one variable or multivariable, the same function can be easily used. And now we will discuss here integration. Okay. For integration, see, I am using here fun is equal to integral. This is integral, and note the function. I is here in uppercase, and I have exponential function with minus x, and I want to use for the definite integral, and suppose that I have x, the limit of x we have 0 to infinity. This is 0 and infinity. For infinity, you have to enter O in lowercase 2 times without space. So this will return us infinity. Okay. And when you will enter and fun print this value, this assignment, and see is there any error. Integral. We have to wait some time. I think there is some okay. Yes, it is fine. So you can see this statement is returning the value, print the value 0 to infinity e raised to power minus x dx. So this is the syntax. If you want to print the value in Python, and if you want to simplify, then you will use the statement. The assignment for the above is fun dot do it, and then enter using the, don't forget about the parenthesis, and then enter. The value after simplification of the above integral we have is 1. Okay, so you can use integration like by using in this way, or either you can directly use integrate I have some from in the keyboard, sin x with respect to x. Okay, and then enter. So the integration of sine with respect to x we have is minus cosine x. So we have the function to integrate is this one. So there are two different ways to integrate any function, whether it is one variable or two variable or three variable. You can integrate single or double integration or triple integration. All the integrations are possible. Okay, whether it is definite or indefinite. See here, I am choosing here f is equal to, I am taking sine x square, sorry, it is a sine x square plus I have y square plus I have z square. Okay, so this is a triple function of three variable, and I want to integrate, I want to see f is equal to, first we need to print just to check. Okay, f is equal to, we have sine x square plus y square plus z square, and as you know, double product is used for exponent. Now we want to integrate this function. It is very quite simple. Just use integrate, and it is f with respect to x. It will take some time. Yeah, so this is the integration of the above function with respect to x. Similarly, if you want to integrate with respect to y, f comma y, okay, and then enter. So all type of integrations are possible. I have one very interesting statement. See, fun is equal to, I have integral, then exponential function minus x square minus y square, and this is function of a two variable, and we want to integrate for both the variables with their limits. Okay, so the limit for x variable we have is minus infinity. This is minus infinity to plus infinity, and for the same y variable we have the lower limit is minus infinity and upper limit is plus infinity. Then enter. Fun is equal to, yes, this is the input. This is the function which we write at this place, and when you will print fun, this will return the value without simplification. So this is the actual expression of the input, and this is the syntax which we use at this place. And the same you need to remember when we will use this SymPy library in Python. This will make very easy to understand and to write the syntax for any type of symbolic mathematical function. If you want to simplify, then what you will do, we need, as we do in the derivative, remember the function do it. Okay, so here fun dot do it. So this will simplify the above double integration from minus infinity to infinity for x and for y, and function we have is e raised to power minus x square minus y square. And see, when you will enter, so the value after simplification of the above double integration we have is pi. So this is the pi value. So in this way you can easily simplify double or triple integration, single integration, whether it is definite or indefinite. All type of integrations are possible by using this SymPy library, and all type of differentiations. Okay, and the same syntax will be used for solving differential equations, differential integral equations, Laplace transform, all type of integral transforms. We employ all these operations in Python library. Okay, so just here you need to understand SymPy library, and once you will do different type of operations by using this SymPy, we can do. Now the last topic here to discuss is limit. It is also very quite interesting part. See here, I am using FUN. This is the assignment. You can use any assignment. Okay, F is equal to, or you can use L is equal to. I am using here limit function, and it is sine x divided by x. Okay, then comma, then x, then 0. Okay, so when you will enter, this is the assignment, and if you want to print, then again enter uppercase L in uppercase. See, yes, so this is the expression. For this expression, we are using this syntax, and this is very quite simple to write any symbolic mathematics function in Python. Just once you need to understand which type of syntax are available in the in Python, and the syntax which are available in the Python are also always available in the all type of libraries which you will use for scientific computing. If you want to simplify, then L, we are using the same function which we use for differentiation and for the integration, which is do it. Okay, do it, then enter. So it will return the value of the above expression, and we know that this will be equal to 1. The another way for the limit is we can use LIMIT, and we are using the same expression, same function, sine x divided by x, then x comma 0, and it will directly simplify and return the value, which is also 1. Okay, so you know, at this place we discuss various type of operations for differentiation, for integration, for limits. So this is the part of calculus, and various operations are still there, but this is the just overview about the SymPy library, which is highly used for scientific computing, and all type of engineering problems, physical problems we can do with the help of this SymPy library. And in the coming lectures we will employ this SymPy library with the help of Python by importing SymPy library in the Python, and then we can easily execute all these operations in the Python directly. But if you don't know about Python and no information, no awareness about the Python, don't worry about this. Just first open this SymPy on any device. You can open in your mobile also. Mobile is very interesting device if you are using properly. Okay, just to use this. I once again at the end I am letting you know. This is the syntax. Syntax for the URL to open SymPy library in any device is just enter live.sympy.org. Okay, note this point. Enter this URL in your browser, and SymPy library will open in your device, and you can practice on these operations which we discuss in here. And I hope you will operate different. You will choose a different type of prompts for the same, and you will enjoy. So thank you very much to attend this lecture till the end. We will come with some new topic with the SymPy. We will try in the coming lecture matrix and determinant, linear algebra, how we can operate all these operations by using SymPy, and this will help you to learning machine learning, deep learning. There are various type of applications of linear algebra. Okay, so thank you very much to see this lecture till the end, and have a nice time. Wait for the next lecture.